So, hello students. Today we see about the common ion effect and what is the effect of common ion effect on the solubility. Okay, first we see the definition. What is the common ion effect means? The depression, nothing but the suppression. Simply the decrease in the degree of dissociation, the degree of dissociation of weak bases or weak acids. Generally we say weak electrolytes, weak acids or weak bases, or generally we can say weak electrolytes by the addition of a strong electrolyte which is having a common ion. Okay, so we take the examples of a weak acid, and we take the example of weak base, and we see how common ion effects takes place. Okay, so first we give the definition. What is the common ion effect? Is the depression or nothing but the suppression, sorry, the suppression in the degree of dissociation, the suppression in the degree of dissociation of a weak acid or base. Just we are taking as a weak electrolyte by the addition of by the addition of a strong acid or base. Here we are taking it as a addition of a strong electrolyte, having a common ion minimum. Okay, containing a common ion, so is called common ion effect. So the suppression means decrease or decreasing the constant degree of dissociation, decreasing in the degree of dissociation. We know the degree of dissociation. Generally we use the degree of dissociation word for weak acids, weak bases, because already we know the strength of acids or bases mainly based on the degree of their dissociation. Okay, for acids, for strong acid, for strong bases, generally we don't consider, because nearly they are having 100% dissociation. So the degree of dissociation thing is comes from mainly weak acids, weak bases, to compare their strength. All strong acids are having nearly 100% degree of dissociation. For weak acids, for weak bases only, we are taking a degree of dissociation to compare the strength of acids and that bases. Okay, so that weak so already weak electrolytes means for weak bases, weak acids, they are having a less degree of dissociation. So again, by the addition of an external compound, an extra solution మనం యాడ్ చేస్తున్నాం. So which type of compound we are adding means we are adding a strong electrolyte, like strong acid and strong base, strong acid or strong base which are having a common ion in it. అంటే దాంట్లో ఉన్న ఒక కామన్ అయాన్ వచ్చేటట్టు ఒక స్ట్రాంగ్ ఎలక్ట్రోలైట్ యాడ్ చేస్తే ఆటోమేటికల్లీ already degree of dissociation weak electrolyte less ఉంటుంది. So that becomes more less, that is known as a common ion effect. Okay, so we see an example for it. So we take an example that is so there is an example is we know acetic acid. Acetic acid is a weak acid. acetic acid is a weak acid, means it is having a very less degree of dissociation. If to this iodine, what is the equilibrium takes place in its aqueous solution? Which equilibrium takes place in its aqueous solution? So that is undissociated part and dissociated part, acetate ion and H plus ion. Okay, so here the main important thing is if so if by the addition of an acid or a salt, any weak electrolyte, any strong electrolyte, it may be strong acid kaavachu, it may be strong base kaavachu, it may be strong acid, strong base, or any salt. Generally salts are also strong electrolytes. Okay, for example, if it is added by the sodium acetate, if sodium acetate salt is added to it, already we know the sodium acetate is a strong electrolyte because it is a salt. Generally salt are having a high dissociation, degree of dissociation. So if by the addition of any acid, any strong electrolyte which is having acetate ion, so an addition of acetate ion. Okay, so what happens? So automatically, for example, we added sodium acetate and if we add sodium acetate to it, what happens? The sodium acetate ions forms what? So there is also formation of CH3CO minus and Na plus. So obviously in the total mixture, now we have the mixture of acetic acid and sodium acetate. So only acetic acid is in the dissociated form, but as it is a weak acid carbon is not 100% dissociated. For example, we are taking it as just 10% of acetic acid is dissociated into acetate ion and H plus ion. So what happened by the addition of sodium acetate? It is a salt. So what happened by the addition of sodium acetate means so it is also dissociates and forming acetate and Na plus in its aqueous solution. So mainly this acetate concentration increases in the products, means there is increase in the concentration of acetate ion, means the concentration at the right side increases in the equilibrium. Automatically the equilibrium shifts towards the left side, that is nothing but towards the backward, nothing but towards the reactant side, means again this equilibrium shifts to the backward. So again there is a formation of some undissociated acetic acid, means so can you guess which formula, which principle we used here? The principle we used is Le-Chatelier's principle. We know the according to Le-Chatelier's principle, if any changes in the pressure, temperature or concentration at the equilibrium, so the equilibrium shifts towards to cancel that change, and if you increase the concentration, it goes towards a decrease the concentration, means if reactant concentration increases, it goes to the forward reaction. If product concentration is increased, it goes to the backward reaction. So here same, if acetic acid lo manaki ochina common ion acetate ion, no extra additional salts lo kuda emundi acetate ion. So this acetate ion, what is the common ion here? So here we have to say, we have to identify what is the common ion. The common ion here is acetate. So acetate common ion only. So automatically right side acetate concentration increasing. So right side concentration increasing, then automatically according to the Le-Chatelier's principle, the reaction takes, the equilibrium shifts from higher concentration to lower concentration. Means the backward reaction takes place. Backward reaction means there is a formation of some acetic acid. So already it is a weak acid, it is having a very less, just nearly 10% of degree of dissociation. Malli backward reaction, and that again there is a decrease in the degree of dissociation. Okay, so the same example we take, for example, if you add not only acetate ion, acetate acid, acetate ion, for example, if you add a strong acid, so దీనికి మనం ఒక strong acid యాడ్ చేద్దాం. Strong acid అంటే, for example, if you take HCl, okay, for example, if you take HCl, HCl add చేస్తే, so what is the common ion in it? The common ion is H plus. So the common ion H plus Cl minus, there is a H plus common ion is there. So H plus common ion kabatti automatic ga, so the H plus concentration at the right side increases. The concentration at the right side increases, so equilibrium shifts towards the back side. Equilibrium shift towards the back side means there is a formation of some acetic acid. Formation of acetic acid means nothing but nothing. It means this degree of dissociation is decreased. Okay, in the same way we take another example by taking a weak base. Okay, just take another example. So it is take another example. So we know that ammonia, so ammonia is a weak base. Okay, actually in the equilibrium, in the aqueous solution generally it is present in the form of ammonium hydroxide. So ammonium hydroxide is nothing but formed actually due to the dissolving of ammonia in water. Means ammonium hydroxide is also a weak base. So when ammonium hydroxide dissociation takes place, we can guess it is NH4 plus and OH minus in its aqueous positions. So by the addition of, for example, what happens? So by adding a strong by adding solid ammonium chloride. So ammonium chloride is a, you can guess it, is acid, base or salt. It is a salt. So salts are generally strong electrolytes. All salts are treated as strong electrolytes. Okay, so by the addition of adding so ammonium chloride, so again we know that ammonium chloride having the, what are the ions? Ammonium chloride ions, actually there is a salt. Salt means just there is only ionic bonds are present. So there is NH4 plus Cl minus are present. So by the addition of NH4Cl, there is increase in the concentration of NH4 plus. Means here the common ion is NH4 plus. So automatically the common ion is NH4 plus. The concentration is increased in the right side. The right side concentration increases means it shifts towards the back side. The concentration of ammonium hydroxide somewhat increased. So already weak base. So weak base kabatti already its degree of dissociation is very less. సో యాక్చువల్గా మనం 4 to maximum 10%, జనరల్గా మ్యాక్సిమం బుక్స్లో మనకి 4 to 5% ఇస్తాడు. బట్ సో వీ కెన్ టేక్ కన్సిడర్ అప్ టు మ్యాక్సిమం dissociation of weak bases or acids up to maximum 10%. So already it is very less degree of dissociation due to the addition of ammonium chloride, the common ion ammonium plus. The concentration of ammonium increases, so automatically the equilibrium shifts to the back side, and there is a formation of ammonium hydroxide, and there is a degree of dissociation some more decreases. But here what is the common ion? So ammonium is the common ion. Okay, means automatically we can say there is also decrease in the soil, degree of dissociation decrease in the day. So automatically nothing but it is compared with the solubility. means the solubility of weak acid, weak electrolytes. Solubility of weak electrolytes is also decreases due to the common ion effect. Okay, this common ion effect is having a perfect, a best application in the qualitative analysis. In the qualitative analysis. So, do we know what is meant by qualitative analysis? Means the procedure in the laboratory we do in the identification of different cations and anions. Qualitative analysis means the procedure takes place in the laboratory to identify the anions and cations in a given sample. Okay, in that analysis, this common ion effect is very useful. Okay. Okay, this is about common ion effect. Now we see some problems based on it. So we see the main problem. So 0.1 m, a weak base, that is ammonia. Solution is found. Solution is found to have OH minus concentration. Find to have a OH minus concentration of 1.33 into 10 to the power of minus 3 m. So here it is important. So the concentration 0.1 m is given for ammonia. Again it is given the concentration of OH minus is 1.33 into 10 power minus 3 m. So because we know in the weak bases, for weak bases or for weak acid, so in the calculation of pH, we also consider its degree of dissociation also. Means in the calculation of strong acids అయితేనేమో మన H plus ions means nothing but acid concentration, OH minus concentration means nothing but base concentration direct గా తీసుకుంటాం. అదే వీక్ యాసిడ్స్ అయితేనేమో we have to consider Ka. అంటే వీక్ యాసిడ్స్కి డైరెక్ట్గా ఇచ్చిన కాన్సన్ట్రేషన్ Ka వాల్యూతో చేంజ్ అయిపోతుంది. And means H plus concentration is somewhat changed compared to the concentration of a given weak acid. In the same, for weak bases also the concentration of OH minus is not exactly to the given concentration of that weak base, because the OH minus concentration of weak base is also depends on Kb value, means base dissociation constant. Okay, so here it is also directly given 0.1 NH3 concentration, and the OH minus ions concentration present in its aqueous solution is 1.33 into 10 power minus 3. So in this there is a three problems are given. Okay, what are the three problems are? So we do the first problem. It is not the option, it is the question. So find the pH. So find the pH of the solution. So pH, so actually pH means it is a base. Base కాబట్టి for bases always we calculate a pOH. So pOH means that is minus log OH minus. So here don't get confused that 0.1 m. So it's OH minus concentration exactly given. So 1.33 into 10 power minus 3. We have to consider OH minus concentration. So that is minus log 1.33. So actually we have to know it's a logarithm value actually. So that is minus log 10 power is 3. I think so we know the log 10 is 1. So the finally the pOH. Actually the log 1.33, I think it is 1 0.24 something is there. So the log 1.33 value is so already calculated, that is 0.124. Sorry. So therefore the pH is equals approximately 0.28. So obviously we know that pH equals, so 11.88. Sorry, it's a 2 pOH, so not 0.28. So 3 minus means we get 2.88. So that is the pH of the solution is 11.12. Next, in the same question, with the help of same details, there is a one more question is given. So actually what is importance of this problem ante, so direct గా just 0.1 m NaH3 each మనం POH find out pH find out చేయమంటే we have to consider the Kb. So just 0.1 m ఇచ్చి 0.1 m అమ్మోనియాకి మనం pH find out చేయాలంటే ఫస్ట్ POH of weak acids, sorry ఇక్కడ weak base కి we have a separate formula, half into pKb minus log C. I have to consider the pKb also because we don't know the how much degree of dissociation. So కాకపోతే ఈ ప్రాబ్లంలో మనకి డైరెక్ట్గా OH మైనస్ కాన్సన్ట్రేషన్ మెన్షన్ చేసింది కాబట్టి we are not used that formula. So OH minus, if OH minus concentration is not given, so they will provide the value of Kb or pKb. Okay. Next, in the same question, there is one more problem is there with these details. What will be the pH of the solution after 0.1 m NaOH is sodium hydroxide is added. We have to find out what will be the new pH. What is the final pH of the solution after the addition of 0.1 m sodium hydroxide. So actually it is a very simply conceptual question. So after there is a 0.1 m is a weak base and it is added by a strong base. Okay, so strong base, weak base. Here NH is a weak base and NaOH is a perfectly strong base. So there is a totally negligible of concentration of that weak base. So therefore we have to consider the concentration of NaOH only for the calculation of pOH. So you write the solution that as NaOH is a strong base, the OH minus concentration of a weak base ammonia so can be negligible. So it is negligible. So now therefore what is the OH minus? OH minus concentration is nothing but sodium hydroxide concentration, that is 0.1 m. Its acidity is also 1. Direct we calculate the pOH minus log 0.1 minus log 10 power minus 1 becomes pOH 1. So the pH value becomes 13. So it become a, so when it is a always strong base is pH value with the 13. Just we have to remember, due to the presence of a strong acid, strong base, due to the presence of a strong base, uh, weak base concentration of OH minus is neglected. So next there is one more question is there in it. So calculate Kb and pKb. Calculate Kb and pKb for. So here, so we know the ammonia. So ammonia in aqueous solution, it becomes NH4OH, and NH2OH dissociation. We know that there is a formation of NH4 plus and OH minus. So how to write the equilibrium constant? Okay, the base dissociation constant can be written as product concentration and OH minus concentration by NH3 concentration. Here main important is why you left the H2O means that is not the effect of H2O as it is a total neutral solution. So that's why we are not considering the H2O concentration. So here what is NH4 plus concentration? So it is nothing but this is also there are 1:1 ratio. 1:1 ratio means the concentration of NH4 plus is exactly equal to the OH minus. The OH minus concentration is given as this. So there is 1.33 into 10 power minus 3. Again 1.33 into 10 to the power of minus 3. So by NH3. So here NH3 is 0.1 the OH minus means if you want to get exactly NH3 concentration means after the suppression it becomes 1.33 into 10 power minus 3. So if you see this value 1.33 into 10 power minus 3 means 0.00133 is very negligible. So here we can write the value. So that is 1.33 into 10 power 10 power minus 3 all square by exactly 0.1 because this value can be neglected as it is very least value. So for to get simple calculation we neglected that value. So actually there is no big effect on the calculation. So finally we will get on this overall calculation we will get approximately 1.8 into 10 power minus 5. So try to calculate it, okay. So this is 10 power minus 6, just we have to calculate this one and this one, okay. So kb is like this. So pkb, we know that pkb means minus log kb So here after this calculation here we get 4.6 or nothing but exactly. Okay, try to remember this value. So approximately, so the for maximum questions for a weak acid for weak bases pKb values are nearly 4 point, around 4.7 something. Okay. Next, okay, we do some more problems in the next class.